all ready to get started on a new chapter. You're probably wondering about your algebra readiness tests. Maybe you're not. Maybe you just want to forget about them. Don't worry, those don't go in your grade book. And I will be getting information out as to how you did by the end of this week. So just put it out of your mind. Just know that it doesn't matter right now in the scheme of things. And you will find out by the end of the week how it went or what my recommendation is for your math course next year. We're going to start chapter 11 today. Chapter 11 is on relations and functions. This is chapter 11, section 1 today. It's about linear equations and graphs. We're going to start today talking about a function. So today we're going to talk a little bit about vocab. So if you don't have it, pause this video and get your book. It will help you as I walk through some examples and go over some of the problems with you. This is page 583, section 11.1. So again, if you don't have it, grab your book. It'll help you. First thing we're going to talk about is some vocab. What are these words we're going to be using? As you know, the vocabulary of math is very important for you to be comfortable with, so that when your teachers use these terms, you know what they're talking about, you know what it means. The first thing we're going to talk about here is relation, okay? And that's a set of ordered pairs. All right, you should know that ordered pairs, you should kind of know what that looks like. And we've done graphing before. All right, an ordered pair is are numbers within parentheses, coordinates, okay? And that relates what we're going to call input to output, all right? One thing that will be good for you to recognize is that input, we're talking about the x values that go in, okay? The x values. We also sometimes will call that the domain, all right? The output, when we discuss what is the output of this, we're talking about the y values, and we often will refer to that as range. Hopefully you can see that. I'm not sure what this lighting does. It's probably kind of crazy. Let's see what happens. Whew. Maybe that's better. Let's go with that. My shadow was making it crazy before, so there you go. So we have input, which we use for x, and domain. Output, we use y, and range. It would be a good thing to put that in your notes. Now, if we're going to call it a function, all right, that means for every input, or x, there is one output, y. What that means, and let's go the simplest terms, is, and this will be a really important concept, if it is a function, the value for x cannot repeat. Okay, again, I'm putting these notes on my board here. I think you should put them on your paper, on your assignment. I'm not there at your house to make you, but it would be a good idea as we move through this chapter. I will expect you to have a grasp of these concepts here. So, if it's a function for every input, okay, there is exactly one output, meaning your x values cannot repeat. However, you will understand in a minute that your y values can, okay? I'm going to leave those notes there for a second. You go ahead and copy those down. I'm going over the highlighted terms from page 583, okay? Now I'm going to look at example 1 on page 583, okay? And it says say whether it's a function or not. So when you look at those examples, I'm not going to go through all the examples. I'm going to go through the guided practices with you because you don't have the answers for those. But you have the answers for the examples. So look at those and study those. Guided practice on page 583. Okay? Number 1, you can see the list of ordered pairs, right? So we're looking at those relations. That's a list of ordered pairs. Is it a function or not? I'm looking at the x values, those first numbers within the parentheses. -2, 2, 4, and -2. I notice, hey, in the x values, -2 is there twice. The first time, -2 is paired with 4. The second time, -2 is paired with -4. Well, our rule for a function is that every input can only be paired with one output. Okay? And in that case, -2 is paired with 4 and -4. So no, that relation for number 1 on the guided practice is not a function. Okay, look at number 2. 3, 6, -3, 4. All those x values are different. For every input, there is a different output. And so yes, guided practice number 2 is a function. Okay? Now number 3, they present the information a little bit differently. Okay? The relation there is presented as in a table, but that shouldn't be new to you. You've seen that kind of thing before. So you look at that table. Again, input, x values. Okay, so you see the list of input at the top. X values, -4, 0, 4, 8. X does not repeat. So it is a function. Notice in guided practice number 3, -4 has a value of 8, an output of 8. You will notice 4 also has an output of 8. In that relation, the y repeats. But that's okay because every input that's in there only has one output. Okay, there is no x repeating. Y can repeat. Okay, that'll be critical for you to get down. On top of page 584, it gives you what I already told you. X, or the input, we often refer to as the domain of relations or functions, and the y value is the range. So, let's look at example 2 on that page. All right? They go through an example there about a soccer team. I'm going to go ahead and use a different illustration. I'm going to work through another one with another formula so you can see something different. Okay? And so I'm going to use an example of an online company selling puzzles during this time. It has been fun because my Emma likes to solve puzzles. And so that's something we've been doing to keep our time occupied. We like to solve some puzzles. So here's the example I'm going to use. An online company is selling puzzles for $5 each. Okay, puzzles. They're $5 each. Shipping is $10 flat rate. Pricey, right? Put your mask on, gloves on, go to Walmart and buy one. You can get it cheaper. Okay, so if I'm going to figure out, all right, the cost for however many puzzles I'm going to buy, the cost would equal $10. Okay, I think we can all agree on that. Plus 5, let's go with P, however many puzzles I buy. Okay, if I buy 5 puzzles, I'm going to put it in there. So in this case, let's figure out, all right, what's the cost if I buy, let's say 5, 10, and 15 puzzles? That'll be my first question. The cost of all those puzzles. Okay? So what I like to do is make a table. Okay? And I would recommend you start learning to solve these this way. You put your x here, you put your y here, and in the middle you put your, what we're going to call your function rule. You might call it an equation. Okay? 5 puzzles. This is my input. In this case, I'm going to go ahead, and although we know that that stands for P, we put in there for puzzles to make our equation. You understand that the x gets inputted. However many puzzles I buy goes there. So I said, let's see how it is for x is 5, 10, and let's say we're planning on a lot of puzzles, okay? So when x is 5, I plug it in to here. 5 times 5 is 25 and 10. My output is 35. So you understand, if I buy 5 puzzles, I'm going to spend $35. Now, when we get into graphing these kind of things, you're going to want to recognize 5 was my input, 35 is my output. So if I was graphing, right, I would go over to 5 and all the way up to, let's say, 35. So we're going to go by 10s here, 20, 30, okay, and I would have a point here at 5:35. Okay, you're going to see how this comes together. Let's say I bought 10 puzzles. You do the same thing, except I'm going to be consistent in my writing here. $5 a piece for 10 puzzles. Okay, if I buy $10, I'm going to end up spending $60. My coordinate there would look like that. Okay, I'd graph that, and you would see I'm going to start to go up and in a straight line for this type of equation. All right, now I've got 15 puzzles. Okay, and as I do that, okay, 15 times 5 is 75, and 10, I'm going to spend $85. And so here are my coordinates. Again, here's my x value, here's my y value, this is my input or my domain, and this is my range. Okay? When you get information like that, sometimes they, you will be asked to interpret, well, what does this information mean? How many puzzles can I buy for $60? Maybe it would ask you that instead of saying how much is it going to cost me? How many puzzles can I buy for $60? In this case, I can look at the graph and look at my information in my table and go, oh, my output for 60 at 60, that was 10 puzzles, okay? So as you're learning to use relations and functions in this information, you're going to be expected to evaluate it. What does that mean, okay? So there's my puzzles example. They give you an example in your book, obviously. You go ahead and work through that. You can read very well on your own. All right. Jump to example 3, writing a function rule. Okay. On this one, it's talking about if I'm given this information. I'm given a table, and you can see on example 3, they give you input and output. Well, they want you to find a function rule. Okay. What does that mean? It means figure out. It's another way of saying, what's the pattern of what they're writing? I'm going to jump to guided practice number 5 because you can see example 3 in your book. Okay, so I'm going to look on page 585. All right, and we're going to look at that table. And I'm going to go ahead and, although they use input and output, I'm going to do X and Y. And we've got 4 coordinates here for points in our relation. 1, -7. Hopefully you can see where I am on number 5, guided practice, page 585. 2, -6, 3, 4, and -5, and -4. Most of you can see a pattern here. What you want to notice first is that in this pattern, these all go up by 1, okay? 1 and 1, 2 to 3 is +1, 3 to 4, you've got a plus 1. That's important. When you look at this bottom pattern, again, you're looking for patterns. Going this way, how do I get from -7 to -6? That is also a plus 1. -6 to -5, again, I added 1. And -5 to -4, I added 1. Now, if you look in your book, on page 584, they're talking about, they're going to use an equation here, and they're going to talk about A as being the change, and hopefully you can see that. Let's see if I run out of room. You can see it. Okay, you can see the change in output, change in input. Interesting enough, when you get to science, you're going to see things like that, and it might look like a change in Y over a change in X. I don't know if you've seen any of that in your science information yet, but at some point, you're going to see some information like that when you're doing formulas. Okay, so what was my change in Y and my change in X? Okay, well in this case, my change in Y was 1. Okay, it was a plus 1. And my change in X was also 1. So this is pretty simple. My A, we're going to call it, equals 1. Now, why do I want that A? Look at again that page on page 584. Okay? We're going to use this for an equation where it says this. Y equals, let's see, make sure I put it all up here like they have it. It's AX plus B, and A stands for that change. Okay? So in this case, it's just Y equals 1X plus B. Well, what does that mean? How do I figure out? Remember, we're going back to writing a function rule, okay? So, I have this change. My change is change in Y over change in X, okay? And I get 1 for A. This is simple. Let me see. The one in your book is pretty simple because it also uses -2 over 2. Let's see. No, it uses +2 and +2. So in that case, your change is 1 as well. It won't always be that way. You are working your way up to much more complicated functions, but this is where you start, okay? So now what you're going to do is substitute using the information in the table, okay? And I'm going to go ahead and just pick a point, and I'm going to use this point, okay? So using this, Y equals X plus B. I'm going to go ahead and erase this over here. Okay, so I'm going to put these numbers in this equation to find B. Okay, Y, -5 equals 1, that was my A, right, times 3 plus B. All right, so -5 equals 3 plus B. I'm trying to get B by itself. Okay, that tells me how to get my function rule. So, +3 minus 3, -8 equals B. All right, that comes up there pretty well. Now, I'm going to take this information and put it back into this. So my formula now says, what's my new function rule? X, and it was just 1x. If you want to put that there, otherwise if it's not there, it's understood as 1, minus 8. All right, so, well, you're asking me, who cares? What does all that mean? If I get my final equation here, and I would just write it as y equals x minus 8. Like I said, you're starting with simple functions. So you're looking at this and trying to figure out, how do I get from x to y? And what is my function rule? How do I get from this to this? What's my pattern? Most of you probably look at that right away and go, oh, you subtract 8. Okay? But I didn't want to start with this because you have to learn this process for when these are much more complicated. So you need to notice the change in x and the change in y in order to find your a. And you need to be able to put that back into this equation for when this is more complicated. You see this is pretty simple, okay? But now this tells you, here we have, what's your function rule? This is your function rule. This is what it's asking for. So for guided practice, number 5, it's asking for this function rule. A function rule looks like y equals x minus 8. You'll recognize it looks like a formula. Back when we did our puzzle problem, we had that function rule. It was y equals 10 plus 5x, right? Remember that? That was our function rule. Whatever we plugged in here would give us the y. That's what we're learning here. What's this pattern? So this pattern says in this case, whatever you have for x, you're going to subtract 8 to get y. Well, does it work? Sure. Put 1 in here. Y equals 1 minus 8, negative 7. Y equals, put 2 in here, 2 minus 8, negative 6. My function rule works for every single coordinate, okay, every relation I have there. So that's the basics for learning how to write a function rule. We went pretty quickly. I only went through one example. Again, example 3 in your book on page 584 works through another example, so you can see that. They give you another one. If you look on example 4 for your standardized test practice, they walk through it one more time, and they show you how to get that function rule. Those I'm assuming you can work by yourself. You can look through those by yourself. Here's guided practice number 5 I did with you so that you could have one more example of how to write a function rule. You should be prepared to do your lesson today. If you have any questions, remember Google Meet from 1 to 2 is your time. I'm there. Come find me. Good luck. Have a great day.